Hello everyone, you're welcome to today's class. Today we are going to continue from where we stopped. We are done with the slab design. So we are now moving on to the beam design. You can see these are the beams. Alright, these are the beams. So but for today we are going to be talking about how the slab transfers load to the beams. Alright, how the transfer load to the beams. Now you can see that this one is two-way spanning slab. Two-way spanning slab. If you don't know how we got this two-way spanning slab, go to our former previous classes. You know how we're able to, arrange this general floor arrangement. So, how is this slab going to transfer load to the beam? This is two-way spanning slab. So the two-way spanning slab transfers load to the beam. This is the shorter span from here to here, then from here to here as well. Right? Then we have from here to here. Okay, so I can join this one. Now, this is a triangular shape. This along the shorter span, then a trapezoidal shape along the longer span. That is how, for a two-way spanning slab, that is how slab transfers load to the beam. Alright, transfers load like this. Alright. Alright, this one transfers to this. This one transfers to this. Now, there is a formula to actually calculate this. But first, what we need to know today is how the load is transferred from the slab to the beam. Now, this is also a two-way spanning slab. For a two-way spanning slab, this shape will also be repeated here. Alright. Just the same way. Please don't mind me kind of like get it from the center. Okay, let me first of all trace the center down. Right, okay. This, 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 this. Right, can I join this one? So trapezoidal shape along the longer span, triangular shape along the shorter span. Alright, now you can represent a dotted line like this to this beam. Alright, because this beam is a continuous beam. So this is a one-way slab. A one-way slab distributes loads. They share it into two. Alright, half will distribute to this one. This is how one way distribute load to a beam. Alright, if you go like this, then if you also share it. Alright, so you can see that when you now want to calculate for the load transferring to this beam, the formula for this one, we'll be talking about the formula here. Then this load, the slab load, will be divided into two to be added to the beam at this this beam. All right, now this is also a one-way spanning slab. we share it into 2. All right. So I'm distribute to this, to this. Then, sorry. Distribute to this, to this. Then this one distribute, half distribute to this bin. All right. Now let us move to the next slab. This one is a 2-way spanning slab. Okay. Now, let me first of all get the center out. Note, this triangular shape is at an angle of 45 from the edge, right? From the corners at an angle of 45 degrees. All right. So this one like this, like this, like this, and like this. So join this up. This is how this will distribute the trapezoidal shape. Now this is the shorter span 3.800. This is 6.800. 6.800. This is the short span. So this is how this one will distribute to this. All right. Then this will distribute like this. This will distribute like this. Okay. Then the final one, which is this, it's a 1-way slab. Half of the shorter span will distribute to this beam. Half of the shorter span will distribute to this beam. So we divide it into two equal halves. Two equal halves. This one will distribute to this. Okay. All right. So this is how all the slab distribute their loads to the beams we have here. We have different beams. So, like I said, we can now name the beams now. We can call this one beam 1. Beam 1. All right. Beam 1 is a continuous beam. With the way we arrange this floor, this is the horizontal. All right. We can start naming the beams, the horizontal beams first, before we now come to the vertical beams. All right. Now this one, now we can call this one beam. This one is beam 1. There's no space to name this one now. I can clean this one. Let me call this one beam 2. All right. Beam 2. You remember we are saying 225 by 450 mm. Recall that all dimensions are in millimeters. All right. Now all the beam size are 225 by 450. Okay. Now this one, now we will call this one beam 3. Okay, we can call this one beam 3. There's no way to put it now. Beam 3. Let me clean this. Let me clean this one. Call this one beam 3. Call this one beam 3. All right. Beam 3. Then we not call this one. Let's say this one. Okay. Let's start by call this one beam 3. Call this one beam 4. Call this one beam 5. All right. Call this one beam 5. 225 by 450. All right. Now we cannot start from the vertical. Let's call this one beam 5. Let's call this one beam. Let's say beam 6. All right. Call this one beam 7. Beam 7. All right. Call this one beam 8. Now, this beam and this beam, they are similar beams. All right. Just that the loadings on this one is more than the loadings on this one. So I can use this beam, can design this beam to cater for this beam. All right. Now, I can call this one, I can equally call it beam 8. Sorry, it's beam 8. Alright. Now, this one, I call this one beam 9. Beam 9. This is 225 by 450 millimeters. Alright. So, okay, this is also a beam. I can go this one beam 10. You have named all the beams right now. Alright, so in our next class, we will now be calculating the loads on the different beams. Alright, because that this one is a triangle. So thank you very much for your time. Study it so that next time when we come, we'll continue the beam design. Thank you. Bye.